So we're going to start with function operations, and then we're going to talk about composite functions. So what are function operations? Function operation is just your normal basic addition, subtraction, multiplication, division, right? It's just using function notations, right? So if we kind of think about it, you have two separate functions, f and g, inside these parentheses, and then we multiply by x. What you normally do is you normally distribute the stuff outside the parentheses to inside the parentheses. And so what that's saying is you have your function f of x, and then you're going to add your function g of x, right? And it works the same for basically all basic operations, right? So even when you're multiplying, right? So you multiply your function f of x with your function g of x. Now, when you add, subtract, and multiply, there's nothing crazy. The only thing we do have to look at is when you are dividing, or you have a rational, or when you have a quotient or division. The only thing we got to remember is that the denominator, right, so the bottom, cannot equal 0. So you're gonna have to probably restrict the domain, right, so that the bottom is not equal to 0, right? So maybe your domain is going to be all x values except some number, right? Unless you have a square root, then we want the stuff inside the square root to be strictly greater than 0, so then you'll restrict your domain accordingly. And so that kind of goes, it just varies on each problem, right? So here we have an example, and we're going to do 1, 2, 3 of these parts just to make sure that we got it down. So the first one says f minus h of x. So what that really is saying is find your function f of x, and you're going to subtract function h of x from that, right? So my function f of x is x squared minus 2x. And I'm going to put parentheses to remind me that I'm subtracting the entire function of h of x, right? Not just the first part. So we have minus 2x squared plus 1, and then I'm going to distribute that negative to get rid of my parentheses. So what we really have is x squared minus 2x plus 2x squared minus 1. And that's going to simplify to 3x squared minus 2x minus 1. The second one, or the second part, it has f times g of x, right? So my function f of x, we're going to multiply that times my function g of x. So my function f of x, and I'm going to use parentheses just to help me keep things straight. So we have x squared minus 2x times function g of x, which is 3x minus 4, and we kind of multiply all of that out, right? So we have 3x cubed minus 4x squared minus 6x squared plus 8x, and then we're going to combine like terms, and I'm going to end up with 3x cubed minus 10x squared plus 8x. And notice how for both of these, I really didn't have to restrict the domain because it's all real numbers, right? There's no division sign, there's no square root, so I don't really have to restrict my domain. But if we look at this third one, right, so this third one is function h over function f of x, right? So what that's saying is my function h of x is going to be divided by my function f of x, right? So my function h of x is negative 2x squared plus 1, and then my function f of x is x squared minus 2x, right? So now if we focus on this, we have to make sure that the bottom is not equal to 0, right? So we have to restrict the domain. And so the reason we wanted to restrict the domain is so that we get a function, right? Otherwise it's going to be undefined because you can't divide by 0. So what we have to figure out is we got to figure out when is the bottom equal to 0, right? When is the denominator? When is x squared minus 2x equal to 0. The reason we want to figure out when that happens is so that we can avoid it, right? So here, we're going to factor out an x, GCF, right? So we have x minus 2, and so I get two x values that is equal to 0. It's equal to 0 at x equals 0 and at x equals 2. So in order for the denominator, in order for the denominator not to be equal to 0, my x cannot be these two numbers, right? So when I write my function h of x over f of x equals negative 2x squared plus 1 over x squared minus 2x, I'm going to put the denominator, right? So we're going to write x cannot be, and I'm going to state the two numbers that it cannot be, right? It can be any other number, but it cannot be these two numbers, right? It cannot be 0, and x cannot be 2. Other than that, x can be any real number, as long as it's not 0 and 2, and then we're good.